for the ultimate academy combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello everyone, good evening to one and all. Welcome to GATE Conqueror YouTube channel. Please confirm the video and audio once so that we can start the session. Confirm the video and audio once. Yeah, hi Lasya, good evening. Confirm the video and audio once. Today we are going to see a very important concept here. Confirm the video and audio. Yeah, clear. Clear, right? Yes. Fine. For remaining also, please mention whether video and audio are clear or not. Meanwhile, I am going to explain today's topic. Yeah. In the last class, we have seen what is meant by system, what is meant by solution, what are the types of systems and what are the types of solutions. The system is system of linear equations, right? We have seen all those things. Along with that, we have seen the problems on non-homogeneous system also. We have seen the problems on non-homogeneous system also. In this session, we are going to start the concept called eigenvalues and eigenvectors. But before going to start that, we are going to see about the homogeneous system also. Because the homogeneous system is like the homogeneous system is also equally important, because the process of finding eigenvector is nothing but finding the solution for homogeneous system only. Finding the solution for homogeneous system only, right? So we are going to start today's discussion with homogeneous system, and we are going to solve some problems on homogeneous system. After that, we are going to start the topic called eigenvalues and eigenvectors. Is it clear for everyone? Yeah. Good evening, Saloni. Yes, clear, right? Yeah. So before going to move into the topic, let me introduce myself here. I am Babu Ande, having 5+ years of teaching experience in GATE and ESE. My subjects are going to be engineering, maths, controls and aptitude. You can use my code HariMath here to get 10% off on Unacademy Plus subscription. Coming to the next one, these are the features of like a Plus course and Iconic course. This is a Plus course where you are going to get live classes and doubt solving session, crash course, weekly test in English and Hindi also. Rank improvement batch is also there in Plus course. Similarly, for Iconic, we are going to have all the features that are there in Plus. Along with that, we are going to have one personal coach and dedicated doubt clearing instructor, and study materials will be provided and study planners will be given. Along with that, study booster sessions will be there. Personalized test analysis also will be given in case of Iconic, right? Yes. Coming to the next one, these are the pricing plans for Plus course for 12 months, 18 months and 24 months. Here you can use the code HariMath to get 10% off here, right? So you can make the payment in no cost EMI also. That means by monthly you can make the payment here. Coming to the next one, these are the pricing plans for Iconic course here for 12 months, 18 months and 24 months. Here also you can use the code HariMath to get 10% off here, right? To get 10% off. So here also you can make the payment in no cost EMI. That means by monthly. This is next one, Unacademy Ask a Doubt. It's a very good feature where you can ask unlimited doubts, and you can ask at any time. There is no time restriction, and you are going to get matches for your questions, and you are going to get high quality video solutions in English and Hindi also. Of course, you are going to get assistance for your homework. Coming to next one, this is Unacademy like live mentoring product. This is only for Unacademy Iconic subscription. Like you are going to get guidance like all the time. Here you can use the code HariMath while taking Iconic subscription here. Coming to the next one, these are the new batches for GATE and ESE 2023 for electrical guys. The batch name is Arohan and it is in bilingual. The new subjects are started from 15th. Similarly, these are the new batches for Arohan for GATE and ESE 2023. This is also Arohan, but this is for ECE guys, and the language is going to be bilingual here. So new batch is started on 15th. So this is Vero batch for GATE 2023 for electrical guys for English speaking, right? Coming to the next one, this is also Vero batch for GATE 2023, but this is for ECE guys and the language is English speaking. Coming to the next one, you can follow me on Unacademy app, learner app, @HariMath. Here tonight at 10 PM, we are having one special class here. We are having special class like where I am going to cover complete differential equations in 2 hours. Complete differential equations, we are going to have some conceptual discussion on differential equation at 10 PM in special class. Like for that you need to download the learner app and you can follow me @HariMath, right? Yeah, coming to the next one, like you are going to get all the updates, materials and daily practice questions in the form of polls in our Telegram channel, GATE Conqueror. You can join the Telegram channel by using the link t.me/knrao123, right? Yes. Now let's get into the session, guys. Yes, Srikanth, hi. Prakash, hi. LK, hi. Shekhar, good evening. Ahmad, good evening. Yes, fine. Right. Now, before going to start the session, before going to discuss about the things and all, let me take 3 equations as an example, a small example, and we are going to understand about infinite number of solutions. Actually, we have seen there are 3 types of solutions here: no solutions, unique solution, and infinite number of solution, right? We know no solution means solution not exist. Unique solutions, we are going to have one value for x, one value for y, one value for z, and so on. But coming to infinite solutions, what is meant by infinite solution here? What is the complete knowledge or complete information regarding the infinite number of solutions we are going to see now? Right? So for that one, let me take an example. As an example, let me take 3 equations here, which is nothing but x plus y plus z is equals to 4 and x plus 2y plus 3z is equals to 6, and the third one is going to be 2x plus 3y plus 4z is equals to 10. Right? This is the system of equations I have taken in order to explain infinite number of solutions. Right? Now try to find the solution for this one. What is the method of finding solution? The method of finding solution for the non-homogeneous system is always same. Here we need to find what is rank of A and what is rank of AB, and what is the relation between rank of A and rank of AB. Based on that, we can say whether the system is having unique solution or no solution or infinite solution. Okay, so let us try to take this equation into augmented matrix form and try to reduce into echelon form and try to give the statement regarding the solution, and after that we will explore the infinite solutions, the information regarding the infinite solution. Is it clear, guys? Is it clear? Yeah. Now let me take an augmented matrix form here, which is nothing but 1 1 1 4. Okay, meanwhile try to solve this system and tell me the answer. What is the type of solution we are having? Infinite solution or no solution or unique solution? So this one is going to be 1 2 3 6 here, and coming to the third one, which is 2 3 4 10. Right? So I have converted the given system of linear equations into augmented matrix form. Right? Now if you try to observe here, we can able to relate the equations. We can able to relate the equations whatever we have taken here, right? Yeah. So in which way we can relate this one? If you try to observe here, the third row which is having elements of 2 3 4 10 can be related with R1 and R2 because if you try to see here, R3 can be directly written as sum of R1 plus R2 here. Sum of R1 plus R2 here. Is it clear, guys? Is it clear? Right? Now if you see here 1 plus 1 2 3, like this one 4 and this one is 10, right? So if I try to make an operation which is nothing but R3 goes to R3 minus R1 minus R2. Okay, if I take this elementary row operation, what I'm going to get here? I'm going to get this one 1 1 1 4 here, right? Similarly this is going to be 1 2 3 6 here. So here I'm going to get 0 0 0 and this one also 0. So in order to comment on rank, so let us try to bring this one into row echelon form by making one more element as 0. Yeah, by making this element as also 0. If I try to make this element also 0, then the complete matrix will become into row echelon form, and after that we can comment directly on the rank, right? Now for that one, let me do one more operation which is nothing but R2 goes to R2 minus R1. Right? So this one will be as it is 1114, and this one will become 0 here, and this one will become 1, this one will become 2, and this is also 2, and this will be as it is here. This will be as it is, right? Now coming to the next one, if you try to see here by observing this matrix directly, we can say the rank of A as 2 and rank of AB also 2. Rank of A as 2 and rank of AB also 2, right? So here rank of A which is equals to rank of AB which is equals to 2, but here if you try to see, the number of unknowns are 3 here. That means this one is less than n here. So that is what the conclusion we got. Based on this conclusion, we can say this system is having infinite solutions or not. This system is having infinite solutions or not. Just respond, guys. Just respond. Yeah. Is it clear or not, guys? Is it clear or not? Yeah. Now, so with this conclusion, we can say this system is having infinite number of solutions. This system is having infinite number of solutions. This is fixed. This is fixed. This conclusion is okay for us. Now let me do one more operation here. Let me do one more operation on this in order to make this one, in order to make this element as 0. In order to make this element as 0, right? So if you try to do here, so let me do R1 goes to R1 minus R2. R1 goes to R1 minus R2. That will make this one as 1, 0, 1, 2. Okay, similarly this one 0, 1, 2, 2 here, and this one will be 0, 0, 0, 0 as this, right? Now from here onwards, let me try to do back substitution. Back substitution. What is meant by back substitution here? That means converting this matrix into again equations form, which is nothing but we are going to get y plus 2z is equals to 2. This is one of the equation, and one more equation is going to be x plus z is equals to 2. X plus z is equals to 2, right? Yeah. So finally we got this one here. Finally we got this one. Is it clear for everyone? Yeah. Clear, right? Saloni, Rasul, perfect. Yeah. Now if you try to see here, we are having two equations here, but we need to find three unknowns. We need to find three unknowns, which are x, y, z here. We need to find three unknowns. Actually, we are having this x, y, z, all these three terms in these two equations, but we need to find three equations. How to find? How to find means we supposed to take one of the variable value as some arbitrary value. For here, if you try to see as this complete last row is 0, and if we are having some non-zero element here, we can be able to get the value of z directly. But here we are having all the elements as 0, so that's why let me take the z as k. That means some arbitrary value I have taken for the variable z here, right? Yes. Now with this knowledge, can I able to say x and y values or not? See here, with this one I can write x value as which is 2 minus z, which is nothing but 2 minus k here. Similarly, the y value we can write which is 2 minus 2z, which is nothing but 2 minus 2k here, which is 2 minus 2k. Is it clear or not, guys? Is it clear or not? Yeah, last year, clear, right? Yeah. Now try to write x, y, z values in a matrix form, in a vector form here. So x, y, z are going to be this one 2 minus k here, and this one will become 2 minus 2k, and this one yeah, actually after making the operation this one will become minus, right? Yeah. Yes. So from that we are going to get this one as z here. Yeah, we are going to get this one as x minus z. So this one will become x plus 2 plus k, and this one will be as this. This one 2 plus k, and this one will be k here. I hope it is clear. Now I hope it is clear. Yeah. Now if you try to see here, this one is having this x, y, z values are completely in the terms of k here. So now let me write this one as 220 plus k minus 2k and k here. Is it clear, guys? Is it clear? Now can I able to write this one? As 220, and if I bring k common out of this one, we are going to get 1 minus 2 1, right? Yes. Now we can say this is the complete solution set, complete solution space for the equations whatever we have taken, right? Yeah. This is the solution space for the system of equations whatever we have taken. If you take whatever the value for k, you are going to get some value that is going to satisfy our equations whatever we have taken, right? So if you take infinite values here, for k, you are going to get infinite solutions. Right? Here we should know about some terms here. Let us suppose if we take the value of k as for suppose 1, then what we are going to get here, x, y, z values, what we are going to get here, we are going to get this one as 3 here, and this one as 0, and this one is 1. Okay, just see whether this 301 is satisfying these given equations or not. 301. Okay, yeah, just try to observe here. 301. Okay, so this one will become 3 plus 1. Okay, so this one 3 plus 3 6, 3 6 1 4. Yes, it is satisfying, it is satisfying, right? So in such a way from here onwards we can take infinite solutions here. From here we can take infinite solutions. From here, if we take infinite values for k, we are going to get infinite values, right? So this is what the solution space here, this is what the complete solution space. But here we should know about few terms here, so here this vector, whatever we are having, that is called as basis here, okay, that is called as basis. And coming to the next one, by taking some kind of k values, whatever the values of vectors we are going to get, that is called span here, and after that we should know about what is meant by dimension of solution space also, At the same time, we should know what is this x and xyz here. Here we are going to take this z as free variable. In this case, z is going to become free variable, and these two variables are become basic variables. Right? If we know these terms, then we can say we are having complete knowledge over the solution of infinite number of solutions. Okay, we are having the complete knowledge over the infinite solutions, right? So now let us try to see the definitions of what is meant by basis, and what is meant by span, and what is meant by dimension of solution space, and what is meant by basic variables and free variables here. So let us start our discussion with the basic variables here. What is meant by basic variables here? See here in the previous example, whatever we have taken, the basic variables actually are going to be this is the definition for basic variables here. The variables corresponding to leading ones in reduced row echelon form. Okay, so the leading ones in reduced row echelon form, the number of leading ones that are present in the reduced row echelon form. So try to see this one only. Yeah, here we have taken this one intentionally reduced row echelon form. If you try to see here, this one is one element and this one is another element. These are the two leading ones in reduced row echelon form, right? So this is related to x and this is related to y. So these two we can say they are the basic variables. And we can say they are the dependent variables also. In fact, they are the basic variables, and here x, y are going to be the basic variables in the taken example, right? Yes, this is what meant by basic variable. The number of ones present in the reduced row echelon form are going to be basic variables here. Those variables also we can say as dependent variables, right? Yeah. Now next see this one. What is meant by free variable here? Here in this case, whatever the value z we have taken here, see here we have taken z, right? So this z we have taken some arbitrary value. We have assigned this z to a arbitrary value, because we can take any value as z. You can take any value as z, so that this variable, this one z is going to be the free variable here. That means this one is called free variable or independent variable or arbitrary variable, because you can assign any value for this one. We can assign any value for this one. Based on this one only, the basic variable values will change. Right? Now this is what meant by basic variable and free variable. Coming to the next one, basis. What is meant by basis here? If you try to see here, in this one, whatever this 1 minus 2 1 is there, this is what called basis here. Right? Yeah. The set of linearly independent solution vectors which can create span to all possible solution is called basis here. Just try to take the notation here, just try to take the definition here. I am going to explain these things by taking one more example, so that it will be clear. Okay, so the basis is nothing but the linearly independent eigenvectors which can create span for the complete infinite number of solutions is nothing but basis. Here. These definitions are going to be very, very important here. So coming to the next one, dimension of solution space, the number of linearly independent vectors which can create all the infinite solutions here. All the infinite solutions here, that is what meant by dimension of solution space. It is going to be represented by n minus r. It is going to be represented by n minus r, right? Yeah. Now, let us try to take an example here. Let us try to take a small example so that you are going to get all the knowledge regarding this one. X plus y plus z plus w plus u is equals to 5 for suppose. 5 for suppose. This is the only equation I have given and I asked you to find the solution. I asked you to find the solution. How you are going to find the solution for this one? We are having total 5 unknown variables here, but we are having only one equation. Only one equation, right? How to find solution for this one? How to find solution for this one? So let me write matrix form here for this one. 1, 1, 1, 1, 1. Okay? And into, so here some all variables will come. This is equals to 5 here. This is equals to 5. Right? Now, if you try to see in the matrix form, we can say the rank of A equal to rank of AB equals to 1, which is less than 5, the number of variables. So it is going to have infinite solutions. It is going to have infinite solutions. So let me write the solution here. Let me write the solution here. X, Y, Z is equals to, which is nothing but 5 minus Y minus Z minus W minus U. Right? So Y will be Y as it is, Z will be Z, W will be W, and U will be U here. You will be U here, right? Yeah. Now, this one we can write. This one we can write like. This one we can write as sum of 5, 0, 0, 0, 0, right? Plus y into. We can write this one as y into minus 1, 1, 0, 0, 0 here. Similarly, plus z into. We can write this one as 0, right? We can write this one as 0. Yeah, we are going to get minus 1 here. Minus 1, 0, 0, 1, 0 here. Plus, yeah, here we are going to get 1. This one is 0. And this one is W into minus 1, 0, 0, 1, 0. Plus at the end, U into minus 1 into 0, 0, 0, 1. Right? Now we have to write the infinite solutions in this format. Now you are going to take whatever the value for x, for y, for z, for u, for w, then whatever the solution we are going to get, that is going to satisfy the given condition, the given equation, or whatever the equation we have taken, right? Yes. Now here if you try to see here, here y, z, w, u are called, okay, these 4 are called free variables here. This is what called free variables here, and x is the only variable which is called basic variable here. And we can say here we can take whatever the value for this one. So this one we can call, this is independent variable here, and this one x is depending upon remaining values. So we can say this one is dependent here. We can say this one is dependent variable, right? Now coming to the solution space, we can say this is n minus r. So n is going to be 5, total number of unknown variables, minus rank is going to be 1. So we are going to have solution, dimension of solution space is going to be 4, because see here, this one 1, 2, 3, 4 here. 1, 2, 3, 4. These are the four vectors that we are having, which can create entire space. Entire space means all the possible solutions it can create. So these 4 are called bases here. By taking different values for y, z, w, u, whatever we are getting, the final vector, that is called span here, and the dimension of solution space is going to be 4 here, right? That is what the meaning of basis, span and all, right? Is it clear for everyone? Saloni, is it clear? Rasul, Lasya, is it clear? Yeah. Now let us move on to the next one. Here. Let us move on to the next one, which is nothing but homogeneous system. Homogeneous linear system. What is meant by homogeneous system here? We know Ax is equals to B is a representation of system of linear equations. If you are having all elements 0 on the right side, then we can say this is a homogeneous system. Right? Yeah, last year, clear, right? Yeah. This is a homogeneous system. Now, what are the ways of finding solution? If you try to see, homogeneous system is always consistent. We can say the first one, homogeneous system is always consistent here. That means we are going to find the solution. There is no point that there is no solution. That means there is no inconsistent. There is no word called inconsistent. Always, all the time we are going to get the find a solution. That's why you can say the homogeneous system is always consistent, right? Now, in consistent, we are going to have two cases all the time, right? Yes. So here in this case, the two conditions, that means a unique solution or infinite solutions, can be defined in two different ways based on the A here. Based on the A. For suppose if A is m by n and x is n by 1 is equals to some 0. Okay. This is one kind of possibility we can say, and the next kind of possibility we can say the A is square matrix n by n, and this is going to be A into x is equals to O. A into x is equals to O. These are the two kinds of cases that is possible in homogeneous case. Now, if you try to see here, I told you this homogeneous is always consistent. That means either it is going to have unique solution. That means unique solution, when you are going to have unique solution, rank of A equal to rank of AB is equals to n here, right? So in that case, we are going to have unique solution. That unique solution is going to have trivial solution. That solution is called trivial solution or zero solution, we can say. Trivial solution or zero solution. And the next one is going to be if rank of A equal to rank of AB, that is true always. But if it is less than n, we can say this is going to have non-trivial solution. Right? Yes. So whenever this coefficient matrix is not a square matrix, then we have to say based on the rank. Of course, all the time we can say by using rank, but here in this case, we can say directly here. Because here A is square matrix here directly. Okay, if you say the determinant of A is equals to 0, the determinant of A not is equals to 0, then we can say this is going to have unique solution, and this case both are same. This case both are same. And similarly, for suppose if determinant is equals to 0, then we can say it is having infinite solutions, which is nothing but non-trivial solutions. Right? Is it clear? So these are two cases possible here. Here as A is square matrix, we can find by using determinant. Here A is non-square matrix, we have to apply the concept of rank. In both the cases, a concept of rank is applicable because determinant is not 0. That means we can say rank is n only. Similarly, determinant is getting 0. That means rank may be less than n. That is the concept behind this one. Right? Yeah. Is it clear for everyone? After this one, we can able to solve some very good problems here. Yeah. So if we are having this knowledge, then we can solve whatever the question that is coming from this homogeneous type. Yeah, Tarunesh, clear, right? Yeah. Now, let us try to see this one as a first example. If you try to see here, in the right side we are having zeros, means x equals to 0, y equals to 0, z is equals to 0. This is satisfies the given equation all the time, right? But here we need to say whether the system is having trivial or non-trivial solution, right? So for that one, let me take this one as 1, 1, 2 here, and similarly this one is 2, 1, 3 here, and this one is 1, 2, 1 here. Right? Yes. Now try to apply some operations and try to bring this one into echelon form. So for that one, we need to do R2 goes to R2 minus 2R1 here. Similarly, R3 goes to R3 minus R1 here. So with that, we are going to get this one as 1, 1, 2 here, and this one will become 0. So this one will become minus 1. This one will become minus 1. Similarly, this one will become 0 here. This one will become 1, and this one will become minus 1. So try to bring this element is also 0 by doing one more operation, which is R3 goes to R3 plus R2, right? So with this one, we are going to get 1, 1, 2 here, and this one 0, minus 1, minus 1. This one will become 0, 0, minus 2. 0, 0, minus 2. So by looking at this one, we can say the determinant is non-zero here. Non-zero because product of diagonal elements we can take, and we can say rank is also 3. So this system is having trivial solution. Only one solution we can say. That is unique solution, which is nothing but x is equals to 0, y is equals to 0, and z is equals to 0. Right? This is the only possible solution for this system of equations. Next, coming to the next one, we can say, yeah. Now this is the system of linear equations we can take. as a second example. Right? Yeah. If this is the system of equations, there is nothing missing in the board. I have given this is only one here. Only one. This is the only system of linear equations. Right? And we need to find all the possible solutions. Here in this case, now you can understand the concept here clearly. For one equation, we need to find 3 unknowns. So we have to imagine, we have to take 2 variables as some arbitrary values here. So let me take z as some k here and y value as something called, let me take this one as k1 and k2. So for that one, we are going to get x value as minus y minus z here. If I try to write complete x, y, z values here, what I'm going to get here, I'm going to get this one as minus y minus z here. Okay, that means we can say by applying this one, we can say this one is going to be minus k1 minus k2 here, and y is anyhow k2 and z is k1 here, right? So let me write these two things in the form of k1 into minus 1 0 1 here plus k2 into minus 1 1 0, right? Minus 1 1 0, right? Now these two are called bases here. Right? So these are the two linearly independent vectors as a basis. So we can say the dimension of solution space, which is n minus r here. Okay, which is n minus r here, 3 minus 1, because the rank is going to be 1 here, which is nothing but 2 here, right? So the dimension of solution space is going to 2 because it is having two linearly independent vectors as a basis for this complete solution space. I hope it is clear for everyone. We have taken 2 examples here. One is unique solution and one is infinite solution. Right? Yeah. Now let us try to solve some problems based on this homogeneous concept here. See this one. What is this one here? A system of equations represented by Ax is equals to O here. Ax is equals to O, where x is the column, that means unknown. X is unknown here. This x is unknown here, and A is matrix containing coefficients. This is coefficient matrix here. We know this information. Has non-trivial solution. This is what important here. It is having non-trivial solution here. Non-trivial solution means infinite number of solution, and rank is going to be less than n here. Rank is going to be less than 1. This is going to be possible when determinant of A is equals to 0. Here, right? Now, what is meant by determinant of A is equals to 0? This is nothing but singular. That is what asking in the question here. When A is singular, determinant of A equals to 0. That means it is going to have rank less than n. So it is going to have non-trivial infinite number of solution. Right? Is it clear for everyone, guys? Yeah, B. Saloni, B is correct. Singular. Simple concept, this one. Yeah. Coming to the next one. Try to solve this problem, guys. This one already we have seen in the very first class as an introduction. In introduction of linear algebra, we have seen this problem. So try to answer this one by using the concept of homogeneous. What is given here? Ax plus by plus cz is equals to 0. Right? And next one is bx plus cy plus az is equals to 0. And similarly next one, cx plus ay plus bz is equals to 0. Right? So this is what the given system, and it is saying that it is having unique solution here. In homogeneous case, what is meant by unique solution here? Unique solution is nothing but trivial solution here. That means here we can say determinant is not is equals to 0 here. That is what the meaning here, right? Determinant is not is equals to 0 here, right? Determinant is not is equals to 0 here. Yeah. Determinant is not is equals to 0. That means this one is going to be A, B, C, right? Similarly, B, C, A and C, A, B. Its determinant is not is equals to 0, right? This is what the given clue. Yeah. So now based on this one, we need to find what this system is having. That means what is the value of this one? A plus B, B plus C, C plus A, and similarly this one is B plus C, C plus A plus B, C plus A plus B, B plus C. Okay, what is the value here? That is what asking. Here the determinant value is depending upon this determinant value, because this is the given clue. This is the given clue. Now try to solve, guys, this one. How to solve this one? So let us try to find the determinant value here. So what is going to be the determinant value here? If I try to take this one as R1 goes to R1 plus R2 plus R3, we are going to get A plus B plus C. A plus B plus C here, A plus B plus C here, A plus B plus C here. Right? Yes. Now similarly this one also, BC, CA, AB. Right? This one is always not is equals to 0. That is our condition. Now let me try to bring A plus B plus C common. After that we are going to get 1, 1, 1 here. BCA, CAB is not is equals to 0 again. So now let's try to expand this determinant here, which is A plus B plus C into, okay, CB minus A square, okay, and minus 1 into B square plus AC, and similarly the third one is going to be plus AB minus C square. This is what not is equals to 0. Here, right? So this is the condition that we got from the given condition. Now what about this one? Here? So based on that condition, how to solve this one? Here we have to apply the properties here. We have to apply all the properties of determinant we have seen in the previous class, and we should try to find the value of this determinant, and we have to relate with the given condition. So for that one, let me bring this one as C1 goes to C1 plus C2 plus C3. In determinants, row operations, column operations, both will exist because data of A equal to data of A transpose, right? So if I try to do this one, I am going to get this one as A plus B plus C. A plus B plus C of 2 times here we are going to get, right? So 2 times of A plus B plus C. Similarly this one is also 2 times of A plus B plus C here. Similarly this one is also 2 times of A plus B plus C here. And this is what we are going to get here. So let me bring 2 common here. Let me write 2 outside here. So 2, 2, 2. We are going to get 2 common here. And this one will be B plus C, C plus A, right? Now this one will be C plus A plus B, and this one A plus B and B plus C. Now try to apply one more operation here. Which is nothing but C2 goes to C2 minus C1. Similarly, C3 goes to C3 minus C1. Okay. So what it is going to become? This one will be as it is here, because this is A plus B plus C. Of course, we are going to bring this common after these operations here. So if I subtract this part from this one, I am going to get minus A here. So this one will be minus A here. This one will be minus B here. This one will be minus C here. Similarly, this one will be minus B here, minus C, minus A. Okay. So this minus, if we take common, this will become plus here. Right? So this is also 2. Right? Now we can write this one as A in one column, right? A B C in one column, and remaining these 2 elements as it is we can write. Right? So similarly, if you try to divide this one, we are going to get same value whatever we got here, right? But with some extra multiplying factor. Here some extra multiplying factor we are going to get as an extra. Yes, of course, this determinant is very big one, we can say, because it's a huge one. A plus B plus C, A plus B plus C, A, B, C and all is there. Like you can take, otherwise you can take directly here. In order to make this simplify, 2 into A plus B plus C we can take common here, right? So that we can write directly again, say in the same way. So what we are going to get here? So here in the first column we are going to get 1, 1, 1, so that if we try to apply the determinant, we are going to get same whatever we got here previously. See here 1, 1, 1, BCA, ABC, BCA, ABC. See this one. The same one we are going to get 1, 1, 1, BCA, CAB, right? Same we are going to get if we bring this A plus B plus C common. Again we are going to get the same one here. You are going to get the same one. Is it clear for everyone? Is it clear for everyone, guys? Is it clear for everyone? Here, if you are using the concept of homogeneous and the properties of determinant, again we are going to get the determinant as not is equals to 0. What is the meaning of determinant not equal to 0 here? What is the meaning of determinant not equal to 0 here? Determinant not is equal to 0 means it is going to have trivial solution, which is nothing but unique solution in this case. Which is nothing but unique solution or only one solution. Or only one solution in this case. Is it clear or not, guys? Is it clear or not? In order to get the answer for this question, we have to evaluate two determinants here and we have to apply the concept of homogeneous also. We have to apply the concept of homogeneous also. But if we know the complete concept, if we know the concept, exact concept, if a system is formed by making some kind of linear operations on other system, then we can say both the systems are equivalent and they are going to have the same solution. They are going to have the same solution. With this single statement, we can make our life so easy. We can say the answer without even taking the pen also. That's why sometimes we have to go through the concept also. We have to go through the concept also in order to get the answer in very less time. I hope you guys understood the difference between the conceptual approach and mathematical approach. Just respond, guys. Just respond. Here I have shown clearly the difference between the conceptual approach and formula approach. Just respond, guys. Is it clear or not? Is it clear or not? This question we have already discussed prior only. Saloni, Lasya, Tarunesh. Just respond. Are you able to got this point or not? Here we have used the concept of homogeneous also and also the properties of determinants also in order to get the answer here. Right? Yeah. Now, meanwhile, let me move on to the next question here. Yeah, try to find the answer for this question, guys. Let A be a 3 by 3 matrix here. Here A is given as 3 by 3 matrix here with rank as 2. With rank value as 2 here. With rank value as 2 here. Right? Now, what is asking here? What is asking here? Now the system of equations Ax is equals to 0. Now the system of equations Ax is equals to 0 will have one independent solution or two independent solution or three independent solution or only one trivial solution. That is what asking here. Let us try to analyze all four options and give me the correct option, guys. First option, trivial solution. What is meaning of trivial solution? Unique solution. For that one, rank of A, like the rank should be equals to 3 here. Rank should be equals to 3 or determinant should be non-zero. Determinant should be non-zero. That means rank should be 3. Rank should be 3. But here in this question, it is given rank as 2. It is given rank as 2. Lasya, B. Yes, perfect. Tarunesh, B. Yeah. Let us try to understand all the four options here. So first one is going to be the trivial solution. Trivial solution X is equals to 0. This is what unique solution here. This unique solution will exist. This unique solution will exist whenever the determinant is not is equals to 0 and rank is equals to 3. But here in this case it is given rank is 2. That means determinant already 0. That means it is going to have infinite solutions here. This is going to have infinite solutions. Right? So that is what the concept first of all. So first option is not correct. Now coming to all the three options, we are having the common word which is independent solution. Which is independent solution. Okay. The number of linearly independent solutions is equals to n minus r here. N minus r here. Right? As it is given a 3 by 3 matrix, it is given as a 3 by 3 matrix. Right? A is given as 3 by 3 matrix. That means A is a coefficient matrix and is given a 3 by 3 matrix means we can say the number of unknowns as 3. The number of unknowns as 3. Right? So that is 3 here and rank is directly given in the question. Rank is directly given in the question as rank as 2. So that we are going to have one linearly independent solution set. One linearly independent solution set. Right? Yes. Lasya B is correct. Tarunesh B is correct. Saloni B is correct. Right? Simple. Yes. Now, is it clear for remaining guys also? Is it clear guys? Just respond once. If we know this formula n minus r, the number of linearly independent solution, then we can say the answer just like that. Right? Yeah. Now, yes, with this one we can say the homogeneous system is over. Like that means the complete system of linear equations got over, because we have seen the non-homogeneous type and we have solved problems on this, and we have seen the homogeneous system and we have solved the problems on this, and we have seen the most important thing, which is infinite conditions, infinite solutions condition, and we have seen all the terms also. We have seen all the terms also, right? Now we are going to see, or let me give a small introduction regarding the eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Actually, we know, mathematically we know expression which is Ax is equals to lambda x here. Ax is equals to lambda x. This is what we know. This is what we know. But here we are going to say this x as eigenvector here. We are going to say this one as eigenvector here, and this one is eigenvalue here. Eigenvalue here. Okay. So in the exam, always either eigenvalue will be asked or either eigenvector will be asked. So our focus is on lambda and x only, but we are not taking care of this a here actually properly. We are not taking care of this a. Actually, the complete information or the complete concept is lies on a only here. A only. If you understand this a properly, then you can get automatically what is meant by x, what is meant by lambda, eigenvalues, eigenvectors. You can able to get that knowledge so easily. But the complete knowledge is lies in this a here. Why? What is happening with this a? What is happening in this way? Actually, this one a, we are going to call this one as transformation matrix. This a is called transformation matrix here. Transformation matrix. Just remember the word transformation matrix. Transformation matrix. Just keep it aside, ax equal to lambda x, and let me take some ax, simply some ax. Let me consider simply an ax here, and I am getting something outside, something right side, which is nothing but b, here. Here this a is called transformation matrix, and this x is called some input, and this b is called output here. B is called output here. What is the meaning of transformation matrix here? What is the meaning of transformation matrix? Let us suppose I have taken some x minus y here, some x and minus y here as b, right? So, but actually my input is here. Here my input is going to be simply x and y only. Simply x and y only, right? Yeah. Now let me write this one right side. Yeah, we can write somewhere, but that doesn't matter. We are going to take xy here. We are going to take xy as input here, and I am getting this one x minus y. How I am getting this one? So try to see this one. Like so, this one we have to write, right? So this one 1 into 0 here, and similarly this one into 0 minus 1, right? As I have taken row matrix, we can write like this, or we can write in some other way also. But if you try to see here, I have taken some input here, which is x comma y, but I got x comma minus y, right? So that means if you try to see here some vector which is having x comma y values here, now it is becoming x and minus y. So x will be positive only, y will become minus x minus y. Okay, so what is happening this one? Why this xy will become x minus y? Because of this one. This matrix is transforming my given input vector to some other output vector, because with this values it is transforming, right? It is transforming. So in this one, in transforming, there will be so many cases here. So as a transformation, we are going to have reflection here, we are going to have shear here, and we are going to have rotation also. And we are going to have scaling also. Right? So based on the values that are present in the transformation matrix, the output will depends. The input vector may reflect, may take the reflection, it may share, it may rotate, it may scale to some other value. It may scale to some other value because the entire thing is there in the matrix A here. The entire information is having in A here. So this A is going to transform my given vector into some other vector, right? So in these vectors, the eigenvector is going to be some special case. The eigenvector is going to be some special case. First of all, let us try to understand what is transformation matrix completely. What is transformation matrix completely? Okay, what is meant by this reflection? What is meant by this reflection? Okay, what is meant by this reflection, rotation and all, where we are going to have the rotation matrix concept here. Okay, so on some questions also there on reflection and rotation, right? So we are going to see all those things in tomorrow's topic, okay, as a concept of eigenvalues and eigenvectors. If you try to see in signals and systems, the same concept called Ax is equals to lambda x, is the main origin for the entire transform theory, because of this transformation matrix only, because it is an indirect representation of system here. It's an indirect representation of a system here. This one is going to be called eigenfunction. As far as signals and systems is concerned. And this lambda is called eigenvalue here. This lambda is called eigenvalue. Okay, this is what gives the beginning to Laplace transform, Fourier transform, Fourier series. Okay, if you try to see the concept of Fourier series and all, they are exactly starting from the concept called eigenfunction. Okay, you are going to have something called e power jt or e power it. Okay, if you use this one as input, you are going to get same e power it, along with some lambda here. So here this e power it or e power something x, we are going to take as eigenfunction in signals and systems, and this one we are going to take eigenvalue. Right? Is it clear for everyone, guys? Without knowing the exact significance, even we solve 100 problems, there is of no use. Okay, so as far as this eigenvalues and eigenvector is concerned, first of all, we should know about this transformation matrix, and we should see some reflection concept here, rotation concept here, okay, and scaling concept and all, and after that we can get into the topic. Right? Is it clear for everyone? Just respond, guys. Is it clear for everyone? In tomorrow's session, we are going to have the discussion on eigenvalues and eigenvectors, where we are not going to solve directly finding eigenvalues and eigenvectors. We are going to start with the transformation matrix, how the transformation is happening for a particular type of vector. In that, the special case is going to be the eigenvector. Right? So the concept of rotation matrix and all will come in the tomorrow's class. Okay? Yeah, thank you, guys. Thank you so much for the session. If you like, share this session. If you are having any doubts on today's session, you can ask. Here we have seen some concepts here today. We have seen so many concepts today. We have seen what is meant by homogeneous system and what is the types of solutions we are having. Yeah. Just ask me, guys. If you are having any doubts, you can ask now. Saloni. Clear? No doubts, right? Yeah. Okay. Thank you, guys.